Okay, let's unpack this. Because looking at this deep dive into the Daily Tech Reader's August 26, 2026 Weather Edition, it really paints a wild picture.
Oh, it really does.
Yeah. I mean, it's kind of like looking at a house where the thermostat is just completely broken in half.
Yeah.
You know, like some rooms are freezing cold and, well, other rooms are literally on fire.
That's exactly what it looks like.
Right. And like if you packed a bag for Sault Ste. Marie in Michigan today, you'd need a good jacket to handle the 68-degree chill and all the showers. But then you walk outside in Phoenix and it's a totally different planet. I mean, National Weather Service doesn't even bother with numbers for it anymore.
Right. They've just given up on the numbers.
Yeah, they officially categorize it simply as VRYHOT. Just VRYHOT.
Yeah, the sheer scale of the divide in today's data is what immediately jumps out at you.
Yeah.
We aren't just observing a typical late summer heat wave. The entire southern half of the United States is just sitting under this incredibly aggressive heat dome. Yeah, and like you mentioned, Phoenix is baking at 116 degrees, and Yuma is right on its heels at 115.
Man, that is just...
And it stretches, right, yeah, and it stretches far to the east, too, pinning cities like Houston and Waco well over the 100-degree mark.
Well, okay, so let's unpack this mechanism a bit, because calling it a heat wave feels completely inadequate for what we're looking at.
Right.
Looking at the data, it behaves much more like a massive, like a cast iron lid getting slammed down on top of a boiling pot, just trapping all that thermal energy and completely refusing to let the lower atmosphere breathe.
That cast iron lid analogy is actually meteorologically spot on.
Oh, really?
Yeah, a heat dome is essentially the sprawling high-pressure system that compresses the air beneath it.
Okay.
So as that air is forced downward, it heats up even further.
Wow.
It creates this completely stagnant, superheated environment that it literally bakes the moisture right out of the landscape.
Which turns everything into kindling, I imagine.
Exactly. It turns all that vegetation into prime fuel for fires.
Right. Okay, so here's where it gets really interesting, though. If it's just a hot August day, why are people in the Pacific Northwest seeing something completely different when they look up?
Ah, yeah.
Because if this high-pressure dome is acting like a heavy lid trapping everything down south, how is the smoke escaping to travel all the way up there?
Right.
Like when you look at the reports for a place like Great Falls sitting at 90 degrees or Spokane at 93 and Yakima at 95, their official weather condition isn't sunny or partly cloudy.
Right.
It's officially listed as smoke.
Yeah.
And O'Pendleton is at 91 with smoke too. So if the pressure is trapping the heat, shouldn't the smoke be trapped underneath it as well?
Well, what's fascinating here is how that high-pressure lid actually dictates the broader atmospheric flow of the entire continent.
Oh, really?
Yeah, that dome doesn't just sit there in isolation. It has so much mass that it physically displaces the jet stream.
Oh, wow.
So it's actively forcing those upper-level winds to bend sharply around its northern edge.
Oh, I see. So the extreme heat in the south turns the landscape into a tinderbox.
Yeah.
But it's the wings riding the periphery of that dome that actually scoop up the particulate matter from those fires.
Exactly. You've got it.
So the smoke isn't really escaping the lid. It's being caught in a slipstream and funneled hundreds of miles away into Washington and Idaho.
Yeah. The thermal extremes in one region are actively manufacturing the atmospheric hazards of another region.
That is so crazy.
Right, because all that energy and particulate matter has to go somewhere. So if we connect this to the bigger picture, the moisture and cooler air that would normally circulate freely across the southern states, they're being aggressively pushed out to the extreme edges of the map.
Which explains why anyone trying to find relief from a 116-degree desert has to navigate such a wild extremes map.
Right, exactly.
So what does this all mean for someone just trying to pack a bag and escape the 116-degree heat? You either flee to the far north, like Anchorage, Alaska, which is sitting at a crisp 61 degrees, or, like we said, Sault Ste. Marie at 68. But you go the other way, you end up walking into a literal wall of water in the southeast.
Oh, yeah, absolutely.
I mean, places like Orlando and New Orleans are sweltering at 95 degrees, but they are absolutely waterlogged with all these widespread thunderstorms.
Yeah, the position of the heat dome, it dictates that humidity trap as well.
Okay.
Because while the high pressure starves the southwest of moisture, the clockwise circulation around the high-pressure center acts like a giant pump.
Oh, I see.
Yeah, so it actively draws intense moisture-laden air from the Gulf of Mexico directly into the southeast.
Wow.
And then it just collides with the coastal air and just dumps rain. The system is essentially hoarding all the precipitation in one corner while it bakes the rest of the country.
That's wild. So we have 116-degree dry heat in one corner, heavy thunderstorms just parked in another, and massive bands of smoke getting pipelined straight into the mountains.
Yep.
It's a highly volatile, completely nonlinear system.
It really is.
Which, honestly, actually makes the bottom half of this daily tech reader report feel incredibly relevant, rather than just like some random tech update tacked onto a weather report.
Absolutely. And this raises an important question about how humanity even attempts to process and model data of this chaotic magnitude.
Right, because it's so complex.
Exactly. Right alongside these extreme weather readings, the source highlights massive leaps in artificial intelligence.
Oh yeah, the OpenAI update.
Right, specifically OpenAI launching GPT 5.6 for enterprise knowledge workers and Moonshot's Kimi K3 reaching frontier model capabilities.
Yeah, it feels like much more than just a coincidence that these two updates are sharing the exact same page today.
Right.
We're looking at atmospheric mechanics that are becoming so complex and interconnected that traditional forecasting models are clearly struggling to keep pace with all the new variables.
Oh, without a doubt. I mean, it takes immense, unprecedented computational power to model the kind of fluid dynamics we just mapped out.
Yeah, mapping all that must be a nightmare.
It is because you're calculating exactly how a heat dome in Texas alters a jet stream that pulls smoke into Spokane while simultaneously trapping Gulf moisture in Louisiana.
Right, it's all happening at once.
Exactly. And the frontier AI models rolling out right now are built on the exact kind of pattern recognition required to digest billions of shifting meteorological data points in real time.
It's almost like we're building digital brains capable of understanding the chaos, just as the physical chaos itself reaches a boiling point.
That's a great way to put it, yeah.
It really makes you wonder, with AI advancing at this breakneck speed, how long until these enterprise models transition from just assisting knowledge workers to actively predicting or even engineering ways to mitigate that 116-degree heat dome?
That is the big question.
Definitely something to think about the next time you pull out your phone to check the forecast.